Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. Today we are going to see some tips and tricks on product rule versus chain rule. Both these rules are used when you have two functions in the question. Therefore, it's often confusing. In order to apply them correctly, you need to identify the functions correctly. That is what this video is going to help you with. First, let's understand what a product of two functions looks like. A product of two functions would be having two different functions multiplied with each other. For example, you can see cos x multiplied by sin x, ln x multiplied by square root x, e to the power of x multiplied by sin x. You can see two different functions here, two distinct functions which are multiplied with each other. Sin x is a function, cos x is a function, ln x is a function, square root x is a function, and they are multiplied with each other distinctly. So f of x multiplied by another function g of x gives you a product of two functions. Whereas composition of two functions would involve two functions again, but one function would be plugged inside the other function. As you can see here, you don't see f of x explicitly, but g of x is plugged into f of x. You still have two functions, but one function is inside another function, which is called a composite function. Let's see some examples here. The same functions that you saw before can be made into composite functions like this. Instead of having sin x multiplied by cos x, if I have sin of cos x, I have cos x plugged into sin x function. Therefore, this is a composite function. Root x plugged into ln x function. Therefore, you don't see ln x separately, but ln of root x is a composite function. E to the power of x cannot be seen now, but you can see e to the power of sin x, which means sin x is plugged into e to the power of x. So, e to the power of sin x is a composite function. So, you should be able to understand which function is plugged into which function. In this case, you will have one outer function and one inner function. The green functions are outer functions and the purple functions are inner functions. Whereas in product form, you will have two distinct functions. F of x will be fully seen and g of x will be fully seen, and you will have two different functions which are multiplied with each other. Let's go a little further into product of two functions. F of x multiplied by g of x. Two distinct functions multiplied with each other. This is a product function. But when this g of x gets into f of x, like this, f of g of x, then we call this as a composite function. The confusion arises when you cannot identify a composite function from a product function. Now that it is clear, you know that you should use product rule for product functions and chain rule for composite functions. Once you can identify product and composite functions, you can easily apply the product rule or chain rule accordingly. So let's say f of x multiplied by g of x is there, which means it's a product function, and you are going to use product rule, which is first function multiplied by the derivative of the second function plus second function multiplied by the derivative of the first function, and this is product rule. In this case, you can see that you need f of x and g of x as it is, therefore they are explicit and you need to be using them in the rule as well. And you can easily see that this is not applicable when you have a composite function like this, because you don't have f of x in composite functions. Therefore, you cannot use product rule for composite functions. Instead, we are going to use chain rule. You have to differentiate the outermost function, keeping the inner function as it is, and multiply that by the derivative of the inner function. And this is chain rule. Let's see some examples to understand better. Sin x multiplied by square root of x. Can you see sin x separately and square root x separately as a full function? Yes, sin x multiplied by square root x, and therefore this is a product function. And we will use product rule for this. First function multiplied by the derivative of the second function plus second function multiplied by the derivative of the first function, and this is the derivative of sin x square root x, which is in product form. Whereas if this square root x gets into sin x like this, which is a composite function now, therefore we will use chain rule for this. Sin function is the outer function and square root function is the inner function. So according to the chain rule, we need to differentiate the outer function first, which becomes cos x. But in the place of x, we have square root x, therefore we will have cos of square root of x multiplied by the derivative of the inner function, which is 1 over 2 root x. Therefore, the derivative of the composite function sin of square root x is cos of square root of x divided by 2 square root of x. Let's see one more example, ln x multiplied by sin x. So, you can distinctly see ln x function and sin x function multiplied with each other. Therefore, this is a product function and therefore we will use product rule. First function multiplied by the derivative of the second function plus second function multiplied by the derivative of the first function will give you the derivative of ln x multiplied by sin x. Now let's say that this sin x is being plugged into ln x, which makes it a composite function like this. You cannot see ln x anymore, but it is ln of sin x, and therefore we will use chain rule. According to the chain rule, the outermost function ln x function, which has to be differentiated as 1 over x, but in this case in the place of x we have sin x, which has to be retained. So 1 over sin x multiplied by the derivative of the inner function here, which becomes cos x. Therefore, the derivative of ln of sin x is cos x over sin x, which can also be written as cot x. Were you able to understand the difference between a product function and the composite function, and therefore will you be able to apply product rule and chain rule correctly? Let's see if you have understood. I'm going to give you some functions here, and you are going to identify whether to use product rule or chain rule for each one of them. And I'll give you the answers in few seconds. On the second column, write whether it is a product rule question or a chain rule question. A few seconds before I give you the answers. The answers are coming now. Did you do them right? Perfect. Thank you for watching. Enjoy more mathematics with Kanitika.com. Bye bye.